like doing this with the class is, if we all see that, and I hear 16 people go, sweet, I got the same thing, and I hear one person go, wait a minute, something's off, it just means you have to go back and check your data and make sure you didn't key something in wrong. I inadvertently, when I was keying it up here, I tried to type negative 27, I hit 327 instead. Now that's a slight bit of a difference, losing 27 pounds to gaining 327. It's ridiculous. It's an outlier, but it's very easy to do when you're plugging along doing numbers. So just double check if we're doing this in class together and you get to that point where you're not agreeing with the screen, go back and look at your data, make sure they're all the same. Okay, the two numbers I want to focus on right now are the sample average, that 18, or the negative 14.7. Let's make the math easy, make it negative 15. Negative 15 what, friends? Pounds. Thank you, Hattie. With a sample standard deviation of about, love it, about 16 pounds. Okay. Interpret those numbers for me. Tell me, as far as the numerical values, yes. That brings up a good point. Jada brings up a good point. They're practically opposites. One's like a positive 16, one's a negative. Just so you know, that can never be a negative number. That has to be a non-negative number. It can be 0 if all the values are exactly the same, but it can't ever be negative. The fact that they're practically numerically the same, 15 and 16, is just happenstance in the data set. That doesn't always happen, as we saw with Bird Dirty. Right, Bird Dirty, 81 average, and a 1 and a 16, whatever it was, as far as standard deviation. That's just, the relative size is dependent on the variability and also the location, the center. So it's kind of a coincidence that they're the same that way. What else? Average of negative 15. What's that mean? Average of negative 15.
On average loss.
Weight loss.
On average, they lost 15 pounds. Good. So if you were telling someone, suppose somebody was interested in using this weight loss program, what would you tell them? Does it work? JC, give me what's on your mind.
Oh, it's
No. Something different you're talking about?
I'm going to combine the two. And
Good for you. Okay, let's come back to you in 30 seconds.
Yeah.
Would you say, go do this, and you'll lose weight?
Yeah.
Would you? Good. Scott, tell me why. Because?
Because on average, everyone lost 15 pounds at least.
On average, we lost 15 pounds. Now remember, the problem with the American public is the misunderstanding of the word average. Because I look at this data, and I see somebody gained 6.
Yeah.
Somebody gained 16. Somebody gained 21.
I'm curious what meal replacement is.
That's what I'm saying. It's been such a long time since I read this study. I gave you the title because I wanted you to go track it down. But Scotty, I love what you're saying. On average, it works. We'll say that again.
It's really not that bad.
Because you're looking at it as, tell me why you're looking at it. Tell me.
Because there's a lot more negatives than positives.
He's going to go with the fact that if I look at this overriding chart and count the negatives and count the positives, which Jenny's already doing, there's going to be, no, this is good. I love what you're doing over there. It looks to me, I'm going to go by, let's go 1. I'm going to count 0 as positive, but that's okay, even though it's bad math. So I got 1, 2, like bad math, 3, 4, 5, 6, 7, 8, 9, 10. I get 10 positives, if that's correct, with the 0 included, and the other 25, 40% positive or 0, if I added it correctly. Which is, it's almost a crapshoot, but it's still more negative than positive. So I like what Scott's saying, especially this percentage idea. I want to try to apply it to what JC is going to say, and I think we can. Can we hold that thought for just a couple minutes? JC, go, please.
Okay, I have 2 questions, or 2 things.
Go!
But I don't want to ask my question.
Okay.
So the average is negative 15, so that's where it's going to start spreading out at.
Good! So that's the center of the data set, and it starts spreading from there, up and down.
then
Good, good.
16 is where it's on either side.
Okay, I love that. Thank you. And this is going to tie beautifully to what Scott just said. What JC just said about putting 16 on either side of average is a very important concept in statistics. And some of you may have heard this in your psych and social classes if you've taken psychology and sociology classes, depending on who you took them with. There is this guy right here is the standard deviation. And it's a number. It is one single number, and it's called the standard deviation. However, as soon as you start taking that number and doing exactly what JC said to do with it, we talk about a range of values, which are called a number of standard deviations, plural. So what I want to do is I want to break down the 3 most common ones, and not to realize, I mean, not to limit them to 3. There are infinitely many numbers of standard deviations. It's just the question is, these are the 3 that are used the most. Let me check the
Can I ask my
screen.
question?
Oh, please, yes, Stacey, I'm sorry, go, yes. Does it depend on the ranges to ask it or no?
What?
The ranges you just described, does it depend on that or no?
No.
Go, then go, let's ask your question first.
So, when we were talking about measures of suspension, and we were
Yes.
talking about average, the X bar, we're talking
Yes.
about fair share.
Good.
When I'm thinking about this, the negative 15 pounds fair share, not everybody, I don't know exactly, it's not matching up because not everybody lost 15 pounds. There's the
It's
positives
exactly
and
right.
negatives. So is that what the standard deviation kind of gets away from? Not necessarily away
It
from,
actually
but-
sheds more light on it.
Yeah.
Yeah, no, that's perfect what you just said. I'm glad you brought the fair share thing up. It's almost like instead of handing everybody lollipops up here,
Yeah, or the keys.
I took them away from them.
Yeah.
Except for the person that gained 21 pounds. I gave them 21 lollipops. But the person that lost 58 pounds, I took 58 away from them. They're debited 58 lollipops. Now, when you have 35 of those people standing up here, the person that I gave 21 to tries to start sharing and realizes I can't share, I don't have the lollipops to share with. They have to go into a debit in order to match the other people that are up here. The fact that they're averaging negative just means, if you go back to the screen, what is this guy right here, this negative 515? That's the sum of all the numbers in the data set, including the positive and negative ones, which means the entire data set lost 515 pounds. If you divide that by 35, that means each one had to average a 15-pound weight loss to achieve that. But you lose the positive and negative by doing that, right? It looks like everybody lost 15 pounds. That's where that comes in and allows us to do what Scott's doing with percentages, but in an even more specific way. What you did was great, pluses and minuses. But we lost something about the direction of where the pluses and minuses are and how extreme they are. Go, Scott.
But we're using negative 15 as baseline.
Correct, but I want to put a second line up there to compare it to too. I love what you're saying. Using negative 15 as baseline basically splits the data set in half.
Right.
Right? But if we slap the standard deviations on there, we get more numbers than just a half, or even the 40, 60 I just talked about. That's why I like what JC and you guys are getting to. Let's tie it in. Let's tie it in. Now the first thing I want to do I want to do it graphically. I do want to do this graphically, but I think this is important enough to kind of take a pause and just bust out to the side and define 3 things, or actually define 1 thing, but explain it 3 ways for you. And this is the difference between the standard deviation and standard deviations in general. This is an apology from me for all statisticians, of which I am not a statistician. I just love statistics. Statisticians decided to name 2 different things using the exact same words. But they're related, so I can kind of get why they did, but I would have liked to have seen them called something slightly different. And here's why I'm okay with it. Here's why I'm okay with it. Here's the first one. We'll call it A, I guess. 1 standard deviation. Okay? 1 standard deviation. I agree, Jenny, it's a little bit silly, but 1 standard deviation is not the exact same thing as the standard deviation. That's my apology. It's a little bit different. My okayness with it, that's a real word, I don't think it is, I just made it up. The fact that I'm okay with it stems from the fact of what it means. What 1 standard deviation is, and technically speaking, there's 3 other words that aren't usually said, from the mean. 1 standard deviation from the mean. That usually isn't said, but it's implied. Here's what it is. It's a range of values. And what it is you start with the average, just like Scotty said, we're using that for baseline. And then you add and subtract, like JC said, the standard deviation from that average. Hence 1 standard deviation away from mean. What this does is it sets up 2 numbers that are the endpoints of the entire interval. More on that in about 15 minutes. We'll come back to why we care about that in about 15. So it sets up endpoints. Let's look at it for our weight loss data. For our weight loss data, X bar is negative 15. We're going to add and subtract that 16 from that. Hopefully the plus or minus symbol isn't pissing anybody off. Sometimes plus or minus makes you think a quadratic formula. Nothing could be further from the truth. Andrew, it's okay, man, it's okay. Put down the pencil. So what is this? What is this? If I do negative 15 minus 16, that's negative 31 pounds. I'm going to put LBS for pounds. Somebody can explain to me why the hell it's LBS if pound starts with P later. What's negative 15 plus 16? That's 1 pound. That range of values is 1 standard deviation from me. What's cool about that is, and you'll often see this in research, they'll just slap that in as 1 standard deviation and not tell you what the average is. But can't you figure out what the average is? It's halfway across. Because that's how you formed it. You formed it by starting at baseline average middle, and then subtracting and adding the 16. So that it's 32 units across. Negative 31 to 1 is 32 units across. Halfway across will be 16 down, or 16 up, depending on how you want to go. So you don't have to know, you don't have to be told the average to know that the average is negative 15 in that interval. Is that fair? Well, mathematically, is that mathematically fair? Okay. Ask me questions about it statistically. What's rubbing you the wrong way right now with that? You might still be forming questions too, but what are your first takes on that? How do you go? Please.
It seems like the majority of people should fall within that.
Makes me happy. Given certain assumptions, you're right. As a matter of fact, everybody go into this data right now and figure out how many of them fall into that range. Go in there right now. Do a count. Do a quick count, Hattie. Please, everybody for that matter. Go into that data. Go into that data. I want to come back. Your point is you're about 22 and a half minutes ahead of me. And I love that. And I don't want to drop what this. There's proof of your statement, but it's going to seem like black magic right now. So hold that thought. I don't want it to seem like, I want it to come logically from. So, but this is good. You jumped us right to this count. How many of those data points? And if you encounter a 1, I guess, is there a negative 31? There is a negative 31 and there is a 1. It's your choice whether or not you want to include those.
25.
If you include them, I get 25. I get 25. 25 if you include them. 23 or 24 if you choose to not include one. Include them. We'll call it 25. That's totally fine. So in our weight loss data, $25 are in this range. Everybody buying that? 25 are in that range. 25 are between negative 31 and 1. Listen to what Hattie said. She said the majority of the data should be within that range. And my response was, assuming certain assumptions, yes. Nothing guarantees it, but for a certain set of assumptions, I can guarantee it. Just not in general. But for a specific set of assumptions, we'll get back to that once we learn how to graph these bad boys. Fair enough? Okay? Do you want to bang out, you know what? Nah, we're at 11. Let's take a pause. We'll bang out 2 and 3 standard deviations next, but you're starting to get that look. So get that look like you want to walk around a little bit. Let's walk around a little bit, then we'll come back and bang these out. And then we're going to show why we care.